Next example. Find the parameters C1 and C2 of a solution of the second order initial value problem consisting of this differential equation and the given initial conditions. X equals C1 cosine t plus C2 sine t is a solution with the two parameters C1 and C2. The differential equation is x double prime plus x equals 0. Initial conditions x at pi over 6 equals 1 half, x prime at pi over 6 equals 0. Our goal is to find out what are C1 and C2 that make this solution satisfy initial condition of this given differential equation. Let's set it aside. What is x prime? X prime is negative C1 sine t plus C2 cosine t for the first initial condition, where x at pi over 6 equals 1 over 2. Which is 1 half. Clean up a little bit. For x at pi over 6 equals 1 over 2. So 1 half equals C1 cosine pi over 6 plus C2 sine at pi over 6. Simplify a little bit. Cosine pi over 6 is square root 3 over 2. Sine at pi over 6 is 1 half. And we see all three terms has the same denominator too, so multiply all by 2. We have the less complicated equation in the form of 1 equals square root 3c1 plus c2 and set it aside. The second initial condition, x prime at pi over 6 equals 0. 0 equals negative c1 times sine at pi over 6 plus c2 cosine at pi over 6. Replace the trig value. Sine at pi over 6 is 1 half. Cosine at pi over 6 is square root 3 over 2. Similar fashion, multiply all by 2. We get 0 equals negative c1 plus square root 3c2. And then we are going to find what are c1 and c2 using the simplified two equations. So from the second equation, C1 equals square root 3 times C2, and then substitute into the first equation. We get 1 equals square root 3 times square root 3 C2 plus C2. Therefore, C2 equals 1 over 4. That gives us C1 equals square root 3 over 4. Therefore, the particular solution for this problem is in the form of x equals square root 3 over 4 times cosine t plus 1 over 4 times sine t. Next example, y is c1 e to the x plus c2 e to the negative x. For the differential equations, y double prime minus y equals 0. With initial conditions, y at 1 equals 0, y prime at 1 equals e. Let's go ahead finding y prime. Y prime is c1 e to the x plus c2 negative e to the negative x, or c1 e to the x minus c2 e to the negative x. For the first initial condition, y at 1 equals 0. B0 equals c1 e to the first power plus c2 e to the negative first, or c1e plus c2 over e. Multiply all by e, we should get 0 equals c1 e to the second plus c2 as a less complicated form of the equation. So y prime at 1 equals e. E equals c1 times e minus c2 e to the negative first, or c1e minus c2 over e. Similar way, multiply all by e, we should get the left-hand side as e squared equals c1 e squared minus c2. To solve these two equations, let's add them together. We should get e to the second equals 2c1 e to the second, or c1 equals 1 over 2. As c1 equals 1 over 2, c2 equals negative c1 e to the second, or negative 1 half e to the second for the value of c2. That resolves the particular solution for this case. Is y equals 1 half e to the x minus 1 half e to the second e to the negative x, or 1 half e to the x minus e to the 2 minus x.